Okay, if you want to conduct a t-test using Excel, you'll first need to get your t-test statistic. So this is found by calculating the mean first of your data set. So I'm going to type equals average, open parentheses, click and drag, close the parentheses. And then we need a standard deviation because a t-test statistic is found by taking your mean, subtracted by the hypothesized population mean, and then divide by the standard error of the mean. So that's your that's your standard deviation, your sample standard deviation divided by the square root of n. Okay, so I've got my mean. I need my standard deviation equals stdev dot s. Click and drag. So I've got this number, I've got this number. This number comes from whatever hypothesis you're trying to test. So let's say I'm trying to test to see if column A is greater than 120. So it's important to note that this is a right-tailed test. And there'll be a different function if it's two-tailed that I'll show you in just a bit. But this is what we're looking for. We want a p-value to tell us the probability that we would get this test statistic given that the null hypothesis is true. If it's a low probability, it means the null hypothesis is unlikely, right? And then n is your sample size, so we've got that. So for mine, my hypothesized mean is 120. So I've got 132.3. Just cut some decimals if you're in my class. 120 for the mean. That's a decimal there. 21.3 is roughly the sample standard deviation. Then divide by the square root of, it's 13. I think I might have said 12, but it's 13 for our sample size because there's 13 numbers in my data set. Okay, so if I'm doing this with a calculator, I'm good at it because I have to do it for my job all the time. I would suggest writing it out step by step. Find out the square root of 13, copy the whole thing. Do 21 divided by 3, divide by the square root of 13, copy everything else down. But since I'm pretty well practiced at it, what I do is I do the square root of 13 first, copy that to my clipboard, so I highlight it and press Control C on my Windows computer. Then 21.3 divided by that square root of the sample size. And so this is my denominator. The denominator is 5.9 roughly. So find out my numerator, subtract those two numbers, and then divide by that denominator. So I got 2.082 roughly. Okay, that's my t-value. And so that's what I need for the function I'm about to show you in Excel. Just writing that down so I don't lose it. Okay, so in Google Sheets or Excel, what you want to do next is, since it's a one-tailed test, I'm typing equals t.dist, and look, it comes up with two-tailed. That's what you would push if it was a two-tailed test. My test was that I'm hypothesizing the mean is greater than 120. If your test says is it likely that the mean is different than 120? Different is non-directional. It could be less or it could be greater than 120. So that would be a two-tailed test. Mine's one-tailed test because I said greater than. I'm pretty sure the first number is your t-value. Second number is your degrees of freedom. So when it's a one sample t-test, it's just your sample size subtracted by 1. So that's 12 because I had 13 numbers. And then I think you want 0 for the next part because this will give you the no, I got it wrong. You want 1 for the next part. You could, or true, either one. Okay, so what that tells you, let me just double check. You could also use an online calculator. So full disclosure, this is my website, t-2.percentile.uk. I'm double checking myself because I was hesitating on that Excel function. Here's my t-value, and then degrees of freedom is 12. Okay, so I should get my website wrong? I think it's wrong. I could fix it. That's a left-tailed probability. Right? That's not right-tailed. It's like it thought I put in a negative number. Here, let's try switching this. Okay, so there's something broken with my website. Let me see if I can refresh. I'm probably not going to cut this out of the video. I want to keep it so I can feel embarrassed. 2.082, 12. There's no negative there. It's acting like it's negative. Okay, so the right tail probability should be 0.03, but it's got a mix for some reason. So that's a left tail probability. This is just like what a table will tell us. Okay, A table tells us the probability to the left of something. The table in the back of a book, the table we see in our Newton problem set, I'm just double checking, it's a 1 that we want. So this is the left-tailed probability. That's what calculators are supposed to default to do as well. So there's roughly 97% of the area to the left. That means we got roughly 0.03 to the right. So that's the big thing we're looking for, the p-value. Okay. So to conduct a hypothesis test for a one sample mean using the t-distribution, which is what you almost always want to use in practice, got to calculate your t-value like I did. Use t.dist with that 1 as the last argument. This is our t-value. This is the degrees of freedom. And then you could use my website after I fix it, right after this video. And so that the area in your tail, which is based on your hypothesis, the area in your tail is your p-value. Okay, and I'll probably make another video about interpreting p-values, but the p-value is roughly the probability that the null hypothesis is true given this test statistic. So we calculate these numbers, we got 2.082. So what's the probability that we got this number, that we got such a big difference between this and 120 if we assume that there actually is no difference, right? There's random chance with everything. You might have just gotten a bunch of people that were stressed out that day because of the random chance of the universe. This is saying there's roughly a 3% chance that this is just random chance. So that implies that there's some sort of effect happening. Maybe the medicine we gave these people has boosted their blood pressure too high because the p-value is low. A low p-value means something is happening here.